Our solar system. We know a lot about our cosmic home, but by no means everything. In its outer reaches beyond Neptune, there are thousands of objects, both large and small. And some of these objects have unusual orbits. Why is this? Could it be that scientists have missed something big?
Nowadays, we know that every star has its planets. Some larger, some smaller, some have more, some less. And our sun is no exception. We have 8, 4 smaller ones in the inner solar system, and 4 gas planets farther out. But what comes after Neptune, the last of the gas giants? Okay, Pluto, but what about even farther out? With our modern telescopes, we've discovered a multitude of asteroids that behave very differently to what we previously expected. Their orbits are clustered, and that's why many astronomers today believe there must be a mysterious 9th planet out there that's behind this.
Our solar system appears to be well explored, but scientists still know little about its outer reaches. These dark regions still hold many secrets. The proposed explanation for the unusual orbits of some trans-Neptunian objects is an undiscovered celestial body, a phantom drifter at the edge of the solar system, a 9th planet.
We see these trans-Neptunian objects and how they're moving, and we can't fully explain their orbits based on the gravitational influence of the known planets. But if there were another one that was in a particular orbit, we would be able to explain them. The interesting thing is that we can even make predictions about this Planet 9. This is just one possible explanation, however. These objects are a long way away. Gravitation is very weak there. There could be other potential explanations.
Should it turn out that an additional planet actually is the reason for the unusual orbits, it would need to have 6 to 10 times the mass of the Earth and be 20 times farther from the Sun than Neptune. The discovery of such a 9th planet would be a sensation. But it cannot be found. Because of this, many scientists think this Planet 9 is just an illusion, a myth.
The planets disturb one another. And there are clearly still disturbances among the outer planets that we can't really explain. Because of this, there's always been this idea of there being another planet out there. As time goes on, it's becoming increasingly unlikely that it exists, however. For 2 reasons. First, we still haven't found it, and we have very powerful telescopes. And second, we're finding more and more smaller objects, where smaller means around 1,000 kilometers in diameter. And that could also explain these disturbances.
The region where a 9th planet is suspected to be is unimaginably large. Researchers have only been able to scan a small part of this area so far, without success.
It would have an orbital period of around 10,000 years. Even Pluto only takes 230 years to orbit the Sun. So this Planet 9 is an awfully long way away. And if it were about the size of Neptune, which would be large at this distance, and bearing in mind the planet doesn't emit light itself, but only reflects the light of the Sun, it would be extremely faint, so you'd need a great deal of luck to see it.
The term planet comes from the Greek and means wanderer or wandering, so it describes a wandering star in the seemingly unchanging pattern of the constellations. An object that slowly moves across the firmament. Planets had already been observed with the naked eye in ancient times, but up until the invention of the telescope, the list remained incomplete. Mercury, Venus, Earth, Mars, Jupiter, and Saturn. Initially, observers included the Moon and the Sun, but then realized that the planets orbit the Sun in elliptical orbits and that the Sun and the Moon were their own categories of celestial bodies. Then in 1891, William Herschel, using a telescope, discovered an as yet unknown planet, Uranus.
He conducted a systematic survey of the sky. That is, he created star charts and looked to see if anything changed from one night to the other. A telescope is ideal for this, of course. And he found it. It was a momentous discovery because it suddenly became clear that there were more planets. And of course, it expanded our view of the world.
But something about Uranus wasn't quite right. Its orbit didn't correspond with the predictions made by Kepler's laws on planetary motion. Something must be causing these anomalies.
A French mathematician, Le Verrier, set himself to the task and made an orbit determination for an unknown planet based on the measurements for Uranus. He then composed a letter to the Berlin Observatory. There was an astronomer called Galle working there, and he asked him if he could take a look at the region where he suspected a new planet might be. Galle checked with his boss and got the okay. So he took an assistant with him, and they had a look. And what do you know? An hour later, they'd found it. This was without a doubt a pivotal moment in celestial mechanics, using a disturbance in the orbit of one planet, like Uranus, to find another in the predicted location, and to do so using a telescope.
Neptune is the first planet whose existence was predicted using mathematical calculations and then found in 1846 at the calculated place in the sky. After Neptune was established as the 8th planet, at the end of the 19th century, the astronomer Percival Lowell postulated the existence of yet another planet beyond Neptune, the so-called trans-Neptune. It was proposed to explain discrepancies in the orbits of Uranus and Neptune. Percival Lowell searched in vain for this trans-Neptune until his death in 1916. Clyde Tombaugh, who had recently been taken on at the Lowell Observatory as a research assistant, was now given the task to continue the search for the planet. He spent roughly a year photographing the region of the sky where the trans-Neptunian was thought to be. Each area, twice, at an interval of a few days. Using a so-called blink comparator, he compared the countless images in order to identify any objects moving across the night sky. On February 18, 1930, he discovered the celestial body being searched for beyond Neptune's orbit, Pluto, the original 9th planet in our solar system.
So how can someone remember the names of the 9 planets in our solar system and recall them in the correct order? There's a nice mnemonic for doing this that many children learn while at school. And it goes like this. The first letter of each word stands for one of the planets. Let's start. My very. Mercury, Venus. Educated mother, Earth, Mars. Just served. Jupiter, Saturn. Us, 9 pizzas. Uranus, Neptune, Pluto. But there is no Pluto anymore. Back in 2006, the International Astronomical Union decided that Pluto isn't a planet. It's now just a dwarf planet, a sort of precursor to a proper planet. And so the mnemonic often used today reads, my very educated mother just served us noodles. Because the list now ends with Neptune.
With a polar diameter of 2,376 kilometers, Pluto is smaller than our moon, but it does have a thin atmosphere composed predominantly of nitrogen. Pluto's orbit is highly eccentric and is inclined at an angle of 17 degrees compared to the orbital plane of the other planets. It spends its time 30 to 50 times farther away from the Sun than the Earth, and takes roughly 250 years to complete one orbit of our central star.
Back when Pluto was still Planet 9, attempts were made to ascribe discrepancies noticed in the orbits of the other planets to the existence of yet another planet. The thing is, you learn at school that all planets move around the Sun in elliptical orbits. But this is only true if there is only one planet orbiting the Sun. Because there's more than one planet, they all influence each other a little bit. Physicists say they disturb one another, and these small disturbances can be explained by adding together the influences of all the planets. But even when all these influences have been accounted for, there's still a small amount left over that we can't explain. And this can be attributed to an as-yet undiscovered planet. It could also be attributed to the precision of our calculations. Maybe we didn't calculate accurately enough. So this idea that there's another planet out there that just hasn't been discovered yet isn't at all new.
It was hoped that Pluto would explain the discrepancies in the orbit of Neptune, but it quickly became clear that it was much too small for this. And so, astronomer Henry Lee Giklas began the search for a 10th planet, Planet X. His photographic survey of the skies lasts 18 years, but nothing is found, thus leaving enough space beyond the orbit of Pluto for speculation.
When people tracked the orbit of Neptune, they noticed deviations from the ideal trajectory there too, and wondered if this could be due to another planet. But after it was determined that Pluto couldn't be responsible, the question naturally arose as to whether there could be even more planets. There could in principle be additional planets, of course. Nothing prevents there being other planets farther out there.
Not long after the discovery of Pluto, it was hypothesized that a whole host of similar cosmic objects existed out there. Travel beyond the orbit of Neptune, and you reach the so-called Kuiper Belt, a region with thousands of icy planetesimals. Pluto is also a member of the Kuiper Belt, and the dwarf planet doesn't orbit the Sun by itself. In 1978, the American astronomer James Walter Christie discovered a Plutonian moon. He noticed a bulge on photos of the planet, a clear indication of a companion. The satellite is named Charon after a Greek mythological figure and alluding to Christie's wife, Charlene. Charon is 1,208 kilometers in diameter, a little over half that of Pluto. As such, it's referred to as the Pluto-Charon binary system. We currently know of 4 other, smaller Plutonian satellites. The Kuiper Belt proves to be a fruitful source of new discoveries for researchers. Ever more unusual objects are found far beyond the orbit of Neptune. At the Palomar Observatory in California, astronomers Chad Trujillo and Mike Brown identify a whole series of remarkable objects that belong to the Kuiper Belt, so-called KBOs, Kuiper Belt objects. Together with astronomer Dave Rabinowitz, they discover Sedna and Eris in 2003. It turns out that Eris is somewhat larger than Pluto. Scientists start to wonder about the known planets.
When these new bodies were discovered, there were a few large ones among them. Sedna was half the size of Pluto and twice as far away. Another, Eris, is roughly the size of Pluto. This prompted the question, if there are so many objects out there, what actually is a planet? Do we really know what the difference is between a boulder and a planet? And if we don't, will there eventually be thousands of planets? And in that case, does it even make sense to talk about planets? Or are we then including piles of debris, boulders, etc. too? So the International Astronomical Union got together and said we need criteria for deciding what makes a planet a planet. There's a smooth progression from Jupiter, Saturn, Uranus, Neptune, and Pluto, and then smaller and smaller still. And at some point we have to draw a line. We have to say, from here, it isn't a planet anymore, but something else. Say, a minor planet.
The International Astronomical Union, the global association of astronomers, responds to the discovery of Pluto-sized solar system objects. and redefines the term planet.
They said that a planet should be round, it should orbit the sun, and it should be dynamically dominant. That is, it should have cleared the neighborhood around its orbit of all the rocky debris. In other words, its gravity should be large enough that it acts like a cosmic vacuum cleaner, keeping its yard clear. Then they looked to which objects meet these criteria, and they saw that Pluto doesn't.
And so our solar system loses Pluto as the 9th planet. The International Astronomical Union made the decision about what counts as a planet at a conference in 2006. The discovery of Eris played a deciding role in this. Instead of classifying Eris as the 10th planet, the astronomers reduced the number of planets to 8 and introduced the category dwarf planet for the demoted Pluto and similar solar system objects that are unable to clear their orbits of other bodies.
There are a whole host of small objects beyond Neptune, the so-called trans-Neptunian objects, or TNOs. And these are relatively easy to classify. Let's look at how we do this. Imagine this is the ecliptic. That is, the plane in which all the planets and these objects move. And let's assume this is the midpoint. This is where the Sun is. And we call this distance between the Sun and the Earth 1 astronomical unit, or AU. Neptune is located 30 times further away, roughly here. And this is the area we're interested in. Beyond Neptune, between 30 and 50 astronomical units, is the Kuiper Belt, namely the classical one where the objects are located in the planetary plane. Beyond that, up to a distance of 200 AU, are the so-called scattered disk objects. These no longer move in the plane, but in inclined eccentric orbits, and scattered because they were scattered outward from the inner region of our solar system during its formation. This is why they no longer orbit in the plane of the planets. Later, some of these scattered disk objects were flung even further outward to a distance of 300 AU. These are the so-called detached objects. And this is where the dubious planet 9 is supposed to be located too. And further out, in excess of 1,000, 2,000 astronomical units, is the Oort Cloud, a collection of millions of much smaller objects.
Named after the astronomer Gerard Kuiper, the so-called Kuiper Belt is a donut-shaped zone beyond the orbit of Neptune. Thousands of solar system bodies greater than 100 kilometers in diameter and countless smaller objects drift around in this region. A vast reservoir of icy rocks of all sizes and the home of many comets. Scientists can still only speculate about the origin of the Kuiper Belt. The ring extends to the outer edge of our solar system, a region almost impossible to study with today's telescopes. Farther out still, beyond the Kuiper Belt, is where some astronomers suspect the as-yet undiscovered planet 9 is located. It would, in their opinion, be a plausible explanation for the unusual orbits of some trans-Neptunian objects. The Kuiper Belt is probably comprised of remnants left over after the planets formed, an enormous source of data that could provide insights into our origins, because it is assumed that the icy objects there have remained unchanged since the formation of our solar system. Whether another ice or gas giant, a 9th planet, could actually have formed out here is disputed.
There are a vast number of small objects there whose growth was stunted very early on in their development. Think of it like this. In the inner solar system, there's a whole lot of mass and somewhat less space. But as soon as you move outward, the amount of space increases exponentially. This means that the likelihood of objects encountering one another becomes less and less. Consequently, they never get a chance to form large aggregations.
The orbits of the small objects in the Kuiper Belt are not particularly stable. So now and then, a KBO, a Kuiper Belt object, is ejected from the belt by Neptune and sets off on a journey of its own through the solar system. If on its way it gets close to our sun, its surface thaws out and the ejected dust and gases form a tail. A new comet appears in the sky. Even further away than the Kuiper Belt is another zone containing billions of rocky fragments, the Oort Cloud. This accumulation of icy debris surrounds our solar system like a bubble. The outer edge of the Oort Cloud is around 1.6 light-years from the Sun. This equates to 15 trillion kilometers. This region cannot be observed directly, but by calculating the trajectories of long-period comets, scientists can deduce that they originated in the Oort Cloud. The material there is in the same state it was when it coalesced roughly 4.6 billion years ago. A comet from the Oort Cloud is thus composed of the same primordial material that formed our solar system.
We currently think that the Oort Cloud extends out to around 1.6 light-years from the Sun. We haven't actually visited any of these objects yet, though. We nonetheless presume that it's from this region of the solar system that comets originate, which is why we can say a little about what we're likely to find in the Oort Cloud. There will probably be several billion objects that are a few kilometers in size, which look the way comets do.
However, scientists can only speculate about the objects that make up the Oort Cloud, their sizes, and how they are distributed.
These are essentially models that have been developed over the decades. And these models indicate that there must still be masses out there. Whereas in the inner solar system, everything has consolidated into a disk. The Oort Cloud is a bit like a bubble surrounding everything.
Our exploration of these far-flung regions of space is still in its infancy. As such, researchers know very little about the outer planets Uranus and Neptune. There's even uncertainty about how they formed. If there really is another planet hiding out there somewhere, one thing is certain: it won't be made of rock.
Can rocky planets form beyond Neptune? No, that's practically impossible. Why? Well, our solar system formed from the collapse of a so-called interstellar cloud, and this consisted of around 99% hydrogen and roughly 1% dust. Dust that today makes up the Earth, for instance. And this dust collapsed quicker than the gas. That's the reason why the rocky planets only formed in the inner solar system, while further out, only gas planets formed. And when you get way out, so little dust was left over that only small boulders could form.
In order to study the regions of space beyond Neptune, in 2006, NASA launched the New Horizons mission. The probe's destination? The Kuiper Belt, and the Pluto-Charon binary system in particular. As New Horizons sets off on its voyage, all is well in the world. Pluto still enjoys planetary status. The space probe's primary task is to study Pluto. The mission is a milestone in the history of space travel. It's the first time that such a distant solar system object is to be visited directly from planet Earth. After traveling for a year, the probe reaches Jupiter. The flyby is used to carry out measurements and observations of the gas giant and its moons. But Jupiter's main role is to slingshot the probe in the direction of the Kuiper Belt. The gravitational force of the gas giant accelerates New Horizons to around 83,000 kilometers per hour and sets it on a trajectory for Pluto. The probe crosses the orbit of Neptune and 9.5 years following launch reaches its first destination, the Pluto-Charon binary system. During its flyby, the probe studies the now demoted dwarf planet Pluto and its largest moon. Spectacular images and data reach the Earth. It's the first time that trans-Neptunian objects, so-called TNOs, have been examined up close.
We've now visited these objects for the first time. After all, Pluto is effectively nothing other than the largest TNO we know of. The other larger ones discovered subsequently also have diameters in the region of 1,000 to 2,000 kilometers. So are relatively large objects too. They're larger than the asteroids in the inner solar system, and their chemical and mineralogical composition is different.
After visiting Pluto, the probe penetrates deeper into the Kuiper Belt, and in January 2019 reaches the trans-Neptunian object Arrokoth, two planetesimals that are joined together. At a distance of just 3,000 kilometers, New Horizons passes the bizarre formation, which has probably remained unchanged since the creation of the solar system 4.6 billion years ago. The probe is set to visit other objects far beyond Neptune's orbit and is expected to remain in service until the late 2030s. New Horizons has yet to discover a ninth planet, but that isn't the purpose of the mission anyway.
We currently know of just over 3,000 objects, but there will be far more objects there. The TNOs haven't really been studied much yet, which is basically due to the fact that they're so far away. You need a really big telescope to discover things like this. And if you also want to characterize them, that is spectrally, you really need the biggest telescope we currently have in order to have a chance of capturing a spectrum that can reveal at least their chemical and mineralogical composition. The problem is that they're a very, very long way away.
Pluto is still the largest object discovered in the Kuiper Belt so far. It has less than 1% the mass of the Earth. In contrast, a ninth planet, which distinguished astronomers suspect exists in this far-flung region, must have a mass several times that of Earth and 500 to 1,500 times the mass of Pluto. It would be much farther from the Sun than Pluto, though, making it difficult to discover with today's telescopes. Despite this, the unusual orbits of a whole group of trans-Neptunian objects could be an indication, and the as yet undiscovered Planet 9 could provide an explanation for this anomaly.
These objects are extremely far away and move around the Sun like everything else. But when you look closely at the orbits of these objects, they cannot be fully explained by the gravitational force of the Sun, but can be if you assume there's a planet out there whose gravity is influencing these smaller objects. From the motion of the smaller objects, you can calculate how big this planet must be, and at what distance it would have to be to cause the small objects to move the way they do. It turns out that you'd need a planet that has roughly 5 to 15 Earth masses. This corresponds to an object about the size of Neptune, and it would have to be located at a huge distance.
Mysterious things are going on in our solar system beyond the orbit of Neptune. At least some of the solar system objects discovered there are puzzling astronomers. One of these objects, with a diameter of nearly 1,000 kilometers, is Sedna, discovered by the American astronomers Mike Brown, Chad Trujillo, and Dave Rabinowitz. Sedna has a highly elliptical orbit. At aphelion, its farthest point, it is approximately 944 astronomical units from the Sun. An astronomical unit is the average distance between the Earth and the Sun, almost 150 million kilometers. It takes Sedna roughly 10,500 years to orbit the Sun. Neptune has hardly any influence on it. Like all large objects out there, it belongs to the so-called detached objects, and is one of the group of solar system objects that exhibit such anomalous orbits.
So, what are detached objects? And why would they be able to explain a ninth planet? Let's take a look at this diagram. This bright dot in the center is our Sun, and this diffuse area surrounding it is the Kuiper Belt. The astronomers say that millions of years ago, a so-called external disruptor flew close by the Kuiper Belt and kicked these objects out. We would expect that these detached objects would now point in different directions. But as you can see, all the orbital axes point in roughly this direction. And that's extremely unusual, statistically impossible in fact. So two astronomers, a Mr. Batigan and a Mr. Brown, come along and say they can explain it. If there were a ninth planet with roughly 10 times the mass of the Earth, as represented by this red ellipse here that heads off in the opposite direction, then the orbital axes of the detached objects could be pulled in this direction due to a so-called gravitational resonance, which means this particular arrangement would explain a ninth planet, if it existed.
The astronomers Konstantin Batygin and Mike Brown use computer models to simulate the mass and orbit of the conjectured ninth planet. Their calculations suggest an object with 6.2 Earth masses located unusually far out in the solar system. Today, we know that there are probably planets throughout the Milky Way, and there appears to be no rule governing their distribution.
We see all possible configurations. There are planets orbiting stars at great distances for reasons we cannot explain. For example, there's a binary star system where the planet, a large planet, several dozen times the mass of Jupiter, is located 15 times further away from the center of the system than Pluto from our Sun. That's a really long way away. We have no idea how such a huge object got there or how it formed there.
HD 106906b is the name of this exoplanet, whose orbit is just as unusual as that of the hypothetical planet 9. It follows an inclined, eccentric orbit at a great distance from the binary star system HD 106906, located 330 light-years from Earth. It was discovered using telescopes at the Las Campanas Observatory in Chile. The discovery of the gas giant casts a new light on the possible existence of a phantom at the edge of our solar system. The star system is still young and surrounded by a protoplanetary disk, a ring of gas and dust in which planets can form. Data from the Hubble Space Telescope should provide scientists with further insights, because according to conventional planet formation models, there shouldn't be enough material for a gas planet to form in an orbit this far from its star. Scientists also consult the Gaia star catalog. Gaia is a space telescope of the European Space Agency, ESA. Its mission is to survey our galaxy, measuring the position, motion, and brightness of approximately 2 billion astronomical objects in order to create a precise, three-dimensional map of the Milky Way.
There are many situations where our classical theories don't fit, and we simply have to come up with new ideas. So we have to remain open-minded. Perhaps there is a large planet further out there after all. There are other exoplanetary systems where it can happen. The Sun with a large planet in the far reaches of the system? Perhaps it is possible. But like I said, we haven't found anything yet.
The eccentric orbit of the exoplanet HD 106906b and its orbital period around its binary star of roughly 15,000 years is surprisingly similar to the assumed parameters for Planet 9.
We're learning a great deal from investigating planetary systems around other stars, including about our own origins. We used to think we understood how things work. Having studied other planetary systems, we now know that things can be very different. The planets can be distributed differently. There are other planetary systems that have Jupiters close to their stars. That is, gas planets orbiting where Mercury is in our solar system. There are also other mass distributions. We need to revise and refine our theory of planetary formation to take these discoveries into account.
Another hypothesis says that this mysterious planet 9 didn't originate in our solar system, but was a galactic wanderer that was captured by our sun. A visitor, which has been bound by the gravitational force of our sun ever since. The idea of an interstellar object in our planetary system is not that far-fetched.
In 2017, an object that definitely came from beyond the solar system passed through the solar system on a hyperbolic trajectory. The object is interesting, no question. Unfortunately, we couldn't find much out about it because it traveled through the solar system pretty quickly.
The object, discovered in October 2017, flew by our sun and passed by the Earth at a distance of approximately 24 million kilometers. Astronomers classified the vagrant as Interstellar Object 1 and gave it the name Oumuamua. They assume that the unusually elongated, cigar-like shaped chunk of rock is a remnant from a planetary collision in another star system. In 2019, a second interstellar visitor to our solar system was observed, Interstellar Object 2, Borisov. Like Oumuamua before it, the comet Borisov, which originated in interstellar space, has already left our solar system again. The pace at which new discoveries are being made by scientists is increasing, and they know that many surprises still lie in store.
In the meantime, we really have seen everything. We've found planets that are so far from their star, and it's possible that the planet formed near to it and then drifted outward over billions of years. We've seen this as well. We've found really huge planets in close proximity to their stars, for instance. And we know in other planetary systems, they must have migrated further out again. In other words, there are various scenarios that can explain how such planets could end up at such enormous distances. So it's not far-fetched for a planet like this to exist.
Other astronomers have come up with a bold explanation that takes a completely different approach. The orbits of the trans-Neptunian objects could be influenced by the gravitational force of a tiny black hole, a so-called primordial black hole left over from the beginning of the universe. The existence of such a low-mass black hole has yet to be demonstrated, however.
This planet 9 could in principle be anything that exerts a gravitational force. Gravity is generated by a mass, so a black hole would produce a gravitational force too. A black hole always sounds spectacular, of course, but when you consider the range of possible explanations and what the simplest would be, and the simplest explanation is often the best, then I think a Neptune-sized planet would be a much simpler explanation than a tiny black hole, bearing in mind we don't even know if such things exist in the first place.
The required black hole with just 5 to 15 Earth masses would only be the size of a grapefruit. Stephen Hawking was the first to postulate the existence of primordial black holes in the 1970s. But the idea is controversial. The mass of a distant planet would thus be the more obvious explanation for the observed phenomenon.
Could the exoplanet we just saw in the film serve as a model for our Planet 9? Well, let's take a look. This exoplanet has 11 Jupiter masses. That is, it's a gas giant, and gas giants fuse their hydrogen and emit vast amounts of heat radiation as a result. And we should be able to detect this with our telescopes. But we don't, so we can exclude this possibility. It could be that Planet 9 is a captured interstellar object, though. What does this mean? Well, a binary star system sometimes ejects one or more of its planets. This planet then drifted through space and eventually bumped into our solar system. This here is the Sun. It entered the solar system and under normal circumstances would have been ejected in a completely different direction. But if the following were to happen, Jupiter is here. This interstellar object approaches and brushes up against the atmosphere of Jupiter. This slows it down, and it's forced into a highly elliptical orbit around the Sun. Something like this could have happened, adding a planet to the solar system as a result. It wouldn't be a genuine planet, though, just a captured one.
For some scientists, the hypothesis of an unknown celestial body at the edge of our solar system simply offers the best option for explaining the unique pattern of the orbits of some trans-Neptunian objects. The researchers who believe in the existence of a ninth planet use computer simulations to calculate the region and path of its presumed orbit. The biggest proponents of this hypothesis, astronomers Mike Brown and Konstantin Batygin, suspect that the ninth planet is located somewhere in a region of space near the constellation Orion. But there's still one catch. While the simulations can calculate the path taken by a ninth planet orbiting the Sun, they can't predict where it currently is. A big problem, because this phantom planet takes an estimated 10 to 20,000 years to orbit the Sun. Telescopes are nonetheless hunting for it. But even the most powerful instruments currently in operation have not yet been able to corroborate the computer models.
The experimental physicist is guided strictly by the experimental results. And the experiment supplies trajectory data for objects with diameters of roughly 1,000 kilometers that I can measure. The trajectory data obviously can't be explained by the gravity of the known planets. So I have to come up with a way to explain these trajectory data. The physicist now considers different models, and the best or most probable model is that there's another planet out there that we know absolutely nothing about. That's the first assumption you'd make. Now you assume the existence of such a planet and use it to try and explain this unknown phenomenon. If you succeed in doing this, you say, okay, now I have to look for this planet. It must be somewhere. Maybe I need to make my telescopes a bit more accurate. I'm sure I'll find it somewhere.
This frozen celestial object far from the Sun would still be warmer than the background space, though. A warm dot against the icy cold of the universe, which would betray the presence of a planet.
If there were such a large planet, you could work out roughly how bright it should be. We know how the Sun radiates. We know that all the small trans-Neptunian objects have very dark surfaces and don't reflect much sunlight. And because of this, it wouldn't be very bright. But it would still radiate in the infrared. NASA's WISE telescope, which takes images in the infrared and has made a detailed map of the sky, should be able to detect such weakly radiating planets too.
The WISE telescope cataloged 560 million objects as part of its mission to survey the entire night sky. Many of them were completely unknown previously. Among the finds was a so-called Trojan asteroid, which has been accompanying the Earth for thousands of years. However, the infrared cartographer didn't notice an extra planet in our solar system. The planet hunters are pinning their hopes on TESS as well. The Space Telescope is actually searching for exoplanets, but evidence for the phantom could be hidden in its data too. During a comparative search, researchers found the previously discovered Sedna in the test data, at least. So the search for the needle in the haystack continues, thus far without success.
The weakness of this Planet 9 hypothesis is that we only know the gravitational force that must be acting on these objects to make them move in their respective orbits. This gravitational force can be generated by a variety of different objects, by a mass distribution, by anything that has gravity. It doesn't need to be concentrated in one place. The model calculations assume that if there's a planet responsible for this gravitational force, it would have to have this size and this orbit. The models can't say whether the planet exists, of course, as this mass could be somehow distributed in space too. The model isn't so explicit on this.
Other astronomers explain the strange orbits through gravitational effects that arise when some trans-Neptunian objects temporarily approach one another and form something like a group. A sort of collective gravity that forces some objects into eccentric orbits. But there's no evidence for this hypothesis either. And the same is true for the mysterious, undiscovered Planet 9.
Our inability to find it increases the suspicion that maybe it doesn't even exist in the first place, in which case we have to consider another model. We need to look at whether the required gravitational force could potentially be generated by just spreading the mass out a bit more in space. But science is always based on what's observed, and new science and new phenomena are always a product of our inability to explain something.
The debate among astronomers regarding the unconventional orbits of some trans-Neptunian objects and their possible cause shows no sign of abating. Simulations don't seem to provide evidence for an undiscovered object of the required size. A plausible alternative explanation is still missing. Celestial mechanics are not governed by chance, but by gravity alone. The topic is controversial and, as a consequence, the subject of heated discussion.
We've looked really hard, so the likelihood of there being another large object out there is fast diminishing. You can naturally speculate all you want. The object could be so far away that even our newest telescopes are unable to detect it. But this is becoming increasingly unlikely.
Thousands of computer simulations indicate that the 4 outer planets exhibit certain instabilities. Perhaps an indication that a 5th giant has migrated even further toward the outskirts of the solar system. Or perhaps this lost planet is nothing but a phantom.
Planet 9 is just a fantasy right now. People say, sure, it's possible that there's something else out there. There are indications here, indications there. And of course, it's interesting to hunt a phantom like this. And we make a lot of other scientifically relevant discoveries along the way. But I don't think I would submit a research proposal for finding Planet 9 today.
Some scientists don't consider the observed orbits as conclusive evidence for an elusive planet. They suspect instead an error in collecting the data, and argue that the objects in question are so small and so far away that it's simply not possible to gather accurate data on them.
Planet 9. Could the whole thing just be a myth? Are these orbits really so uniformly clustered? Well, we lack better data. We need more objects that confirm to us that the orbits are clustered and that they are being influenced by, for instance, this Planet 9. But even if this clustering were to be confirmed, there could be other possible causes. This ominous black hole, for example. We will know in the future. We'll have better telescopes, and I think in 1 or 2 decades, we will know for sure whether this mysterious Planet 9 exists or not.
The dark outer reaches of our solar system still hold many secrets. The primary goal of the scientists is to understand how our solar system formed. The primordial material that likely makes up the celestial bodies beyond the orbit of Neptune could hold the answers to some important questions. How did the planets come to be where they are today? And why are they so different? What was the exact process by which our world formed? The search continues, including for the mysterious ninth planet.